All right, so now let's go and do a quick little review of geometry, because even though precalculus has a ton of the algebra too, there's also a lot of trig and triangles that's going to be going on. so, so if in this case I have solve for x and y, so in this case, hopefully you recognize the Pythagorean theorem, right? Remember, a squared plus b squared equals c squared. So in this case, I have a 9 squared plus a 12 squared is equal to a x squared. All right, so this is going to be an 81 plus 144 equals an x squared. That's going to be 225 equals a x squared. So take the square root of both sides and you get x equals a 15. It's not plus or minus in this case, because obviously the sides of a triangle need to be positive for our example, but hopefully you can recognize here that this is what we call a perfect, I should have known this, a perfect, Pythagorean triple, right? So that means all the side lengths are going to be an integer. So that's something to remember, is those Pythagorean triples. All right, now let's go and look into our special right triangles. And so this is a 45, 45, 90 triangle. So hopefully you need to remember that this is an isosceles triangle. So therefore x is going to equal a 2 square root of 2. Now again, you could use the Pythagorean theorem again if you want to, but it's really important to recognize that that to go from my legs to my hypotenuse, all I need to do is multiply by another 2. So this is going to be a 2 times your x, like times whatever your legs are. So to go from here to here, you multiply by the square root of 2. What I'm going to do here is now say y is equal to a 2 square root of 2 times a 2 square root of 2. Okay, so 2 square root of 2 times 2 square root of 2, that is going to equal a 4 times square root of 2 times square root of 2, which is 2. So therefore that's going to equal an 8. Over here, hopefully this is not a Pythagorean triple, 6, 8, 10. I think this is a Pythagorean triple. So hopefully you can recognize that that is going to be 10, or this is going to be an 8. Again, that's really important. See how quickly I did that? Like, know your Pythagorean triples. That's very, very helpful. You could also use Pythagorean theorem. So you could say 6, squared plus a x squared equals 100 squared. Well, that's a 36 plus x squared equals not 100 squared. That's just going to be a 10 squared, right? So, but a 10 squared is obviously 100. So 10 squared, which is 100, and then you could subtract a 36, and you get x squared is equal to 64. And what do you know? Miss McLogan was right. Thank you very much. Okay, now in this example, again, remember to go from here to here, we multiply by the square root of 2, right? So to go backwards, to go from a hypotenuse to the leg, I'm going to divide by the square root of 2. So basically, I just want to know, well, what is 4 divided by the square root of 2? Well, just rationalize your denominator here. And what you have is a 4 times the square root of 2 divided by 2, which is just going to equal a 2 square root of 2. And remember, x and y are exactly the same. So therefore, x is equal to y, which is equal to a 2 square root of 2. Now, the relationship between my 30, 60, 90 triangle is kind of similar. Or it's not really kind of, well, it is kind of similar. To go from I have 2 legs and a hypotenuse, right? So, because obviously the legs are not the same like they were for an isosceles triangle. So the relationship here of this triangle is from short leg to hypotenuse, you're going to multiply by 2. And to go from short leg to long leg, you're going to multiply by the square root of 3. And again, if you're going to go backwards, you're just going to divide by these terms. So if I want to find x, that's going to be a 4 divided by 2. Right? Which is just going to equal 2. So now I know x equals 2. To go from x to y, I multiply by the square root of 3. So y is equal to my x, which is 2, times the square root of 3, which is just 2 square root of 3. Over here, it looks like this is the short leg and that's the long leg, right? So again, to go from short leg to hypotenuse, in this case, I'm just going to take my short leg, so 4 square root of 3, and I'm just going to multiply that by 2. That's going to give me an 8 square root of 3. To go from short leg to hypotenuse, or short leg to long leg, you multiply by the square root of 3. So y is equal to the square root of 3 times a 4 square root of 3. Well, I can multiply square root of 3 times square root of 3. That's going to be 3. 3 times 4 is going to equal a 12. Over here, you're just going to work backwards again, right? Again, another 45, 45, 9 triangle. So my x equals a 7 square root of 2 divided by square root of 2. Well, that's just going to equal a 7, right? And y then is also going to equal a 7. Now what we need to do is understand our relationships for trig, because obviously we don't know if this is a special right triangle and we don't have enough information. Well, actually, we want to find the angle. So the Pythagorean theorem is not going to help us out. So what we need to understand here is, if here's my angle, okay, here is my hypotenuse. The angle between the right angle and my angle is what we call the adjacent side. And the side on the other side is what we call the opposite side. All right. So when I have the hypotenuse and the adjacent, we need to understand our trigonometric functions. So I have the hypotenuse and the adjacent side. So I'm going to use the cosine function. So what I can say is the cosine of x, right, which is my angle, is going to equal to my adjacent, which is 8, over my hypotenuse, which is 18. So therefore, x equals the cosine inverse of 8 over 18. So if I want to undo cosine, I want to find out the value of that cosine, I need to use the inverse function. Make sure your mode is in degree mode when you go ahead and type in your calculator, and you just do cosine inverse of 8 over 18. You don't need to simplify it to 1/9. You can just leave it exactly as it is. And in this case, x is going to equal a 63.61, and I'll just round to the nearest hundredth degree. So now let's go and do another one. So now we have an angle, right? So that means that's my adjacent side. This is my opposite side. Okay, so in this case, we have the opposite and the adjacent. So now we're going to use the tangent function. So I can say the tangent of x. I guess I should probably like review all the functions, right? So we have three main trigonometric functions. The sine of a angle x is equal to the opposite over the hypotenuse. The cosine of x is equal to the adjacent over the hypotenuse. And the tangent of x is equal to the opposite over the adjacent. All right. So now I'm going to have tangent of x is equal to actually, I don't have enough information. I wrote adjacent, but we don't have anything for the adjacent. We have the hypotenuse. So we're not going to use tangent. We're going to use the opposite over the hypotenuse. We're going to use sine in this case. So therefore, let's rewrite this. So I'll have a sine of x is equal to opposite over the hypotenuse, right? So that's going to be a 10. Or, I'm sorry, I'm losing my mind. We know what the angle is, right? So I can say the sine of 65 degrees is equal to the opposite over the hypotenuse. So that's going to be a 10 over an x. Cool. Now I need to solve for x. Well, obviously to solve for x, you need to multiply by an x on both sides and then divide by sine of 65, right? So when you multiply by an x on both sides, you get x times the sine of 65 degrees equals 10. And then to solve, you need to divide by the sine of 65. On both sides, so sine of 65. So now what I'm going to have is x equals a 10 over the sine of 65 degrees. Now what I simply need to do is, again, plug that in. So I'll just do a 10 divided by the sine of 65 degrees. And now I get a x equals 11.03. And again, I'll just use that to the 100th.